So I'm going to start with today's session 12C, whatever you guys have missed. Okay. Exercise 12C, question number 6. How many different words can be formed of the letters of the word melon curve so that no two vowels are together? Okay. So when I say melon curve, we'll first classify. So these are the vowels, and no two vowels should be together. They should be separated with a consonant, or they should be at the end point. Okay. So I've classified between vowels and consonants. Okay. Now see, if you take a good look at this, there are five consonants: C1, C2, C3, C4, C5. Okay. So these are five consonants. Okay. And I'm just marking some stars over here. I'll explain what is the meaning of this star. See, the consonants can be arranged at the places C1, C2, C3, C4, C5. Okay. Now the stars are the available places for vowels. Stars are the available places for the vowels, because the vowels are, no two vowels are supposed to be together. Okay. So they will be separated with a consonant, or they can be at the end points. Okay. So vowel 1 can be arranged in 1, 2, 3, 4, 5, 6. 6 ways. Vowel 1 can be arranged in 6 ways, because there are 6 places for vowel 1. And vowel 2 can be arranged in 5 ways. Okay. Because out of 6, one place is already utilized by vowel 1. So there are 5 remaining places for vowel 2. And vowel 3 can be arranged in 4 ways. Okay. So if vowel 1 is arranged over here, okay, so there are 5 places for vowel 2. Okay. If vowel 2 is arranged over here, there are 4 places left for vowel 3, the 4 tick marks. Okay. So this is how the vowels will be arranged. Now we also have to arrange the consonants. Okay. So I'm going to the next
So will
page.
it be 6 into 5 into 4 into 3 into 2 into 1?
No, because after the third vowel, there is no fourth vowel. Na?
Oh, we have
And
only 3.
yeah, we have only 3 vowels. Correct. Okay. So now we should think about the consonants. So total objects n is equal to 5. And for consonants, there are 5 places: C1, C2, C3, C4, C5. There are 5 consonants and there are 5 places. Okay. So total places.
So I didn't understand how there are 3 vowels but 6 places.
See, basically, between two vowels, there has to be a consonant if no two vowels are together. Agreed?
Yeah.
Or they can also be at the end point. So this star, wherever I have marked star, now these are the available places for vowels.
Okay.
Okay. So the first vowel, if for example I'm making the first vowel to, occupy this particular place, the second vowel will have 5 places left, the 5 stars. Okay. So if the second vowel is sitting over here, so how many places are left for the third vowel?
Oh.
4. So the fourth vowel is sitting over here. Okay. Now what will happen of this remaining stars? Remaining stars will hold no meaning. Okay. Are you understanding or not understanding?
Yes.
Okay. So in that particular case, C1 and C2 consonant and C3, C4, C5 has to be together. And that doesn't contradict with the question. Consonants can be together, but then vowels should not be together. Okay.
Yes.
Yeah. So for consonants, there are five objects. Okay. Which are ML, N, K, V, and five places C1, C2, C3, C4, C5. So the number of arrangements are NPR, 5P5, 5 factorial ways. Understood?
Yes. Yeah.
So the total arrangements for the first part of the problem is equal to 6 into 5 into 4 into 5 factorial. Okay. Are you able to understand this? Yes or no?
Yes.
Okay. So if you want to copy, I'll just take you to the first slide once again. If you have copied, let me know. I'll go to the next slide.
Can you go ahead once?
Sure. Done?
Yes.
Okay. Second sub question. The vowels will or may occupy the odd places. So see, I'm just making uh, a total of 8 boxes because there are 8 letters in the word melon curve. Okay. So the vowels will take up these places 1, 3, 5, 7 because the vowels are going to occupy the odd places. So vowel number 1 can be arranged in 4 ways. Do you agree, guys?
Yes.
We can place the first vowel. We are having 3 vowels, right? So vowel number 1 can be placed in 4 ways. And vowel number 2 can be placed in 3 ways because out of 4, one place if it is utilized. So there will be 3 places left for vowel number 2. Okay. And vowel number 3 will be arranged in 2 ways. Okay. Now if the 3 vowels are arranged in this manner, one vowel over here, one vowel over here, and any one vowel over here. So this particular place is left vacant. Do you agree or not? Because there are only three vowels. So place number 5, box number 5 will be not utilized. Do you agree?
Yeah.
So this particular place will be utilized by whom?
Consonant.
Yeah, because consonant will certainly require one place. Na? Consonants, there are four places. Okay. Consonant, 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 consonant. But there are total five consonants. So this particular place will be used by a consonant. So I'll just write down for consonants. Total objects n is equal to 5. Total places r is equal to 4 plus 1. Why I'm writing 4 plus 1 is because, okay, so this is one place, second place, third and four places for consonant, and this place as well. So I'll just write 4 plus 1, where I'll just write besides 1 that one place left vacant by vowel. So this is also equal to 5 NPR 5P5 5 factorial. NPR 5P5 5 factorial. Okay. So total arrangements. This is equal to 5 factorial into vowels arrangement is 432. Vowels arrangement is 432. So if you want to copy, I'll just take you to the previous page. Please copy this. If you're done with this slide, then let me know.
Yes.
Okay.
So out of 1357, it can be like any box that's left vacant, right?
Sorry, come again.
So out of 1357, any of the boxes can be left vacant, right? Like any one.
Yeah. Correct. I just gave an example of 1, 3, and 7. It can be 1, 3, and 5 also. No?
Yeah.
So if 1, 3, and 5 places getting utilized, seventh place will be left vacant.
Yeah, good.
Okay. Should I go to the next problem?
Yes.
Yeah. So let us go to Acha. This sixth and seventh problem are very important for your exams. Hence, you need to practice it well. Question number 6. The word is combined. In how many ways the letters of the word combine can be arranged so that the vowels are never separated? The vowels are never separated, meaning is they are always together. Second part, all the vowels never come together. Okay, and third part, vowels occupy the odd places. So now see, the vowels are never separated. That means the vowels are always together. And the next part is the vowels are never together. So if the question is always together or never together, okay, so in that case, what you need to do is you need to first find out total number of arrangements. So I'll just write the word combine. Now total arrangements without putting any condition on it. N is the total number of objects. So it is 7. R is the total number of places. 7 objects. For 7 objects, will make 7 boxes, right? So there will be 7 places. So R is equal to 7. NPR 7P7, which is if the upper number and lower number is same, we can use a shortcut 7 factorial. Do you know this?
7 factorial less than 7 into 6 into 5 into 4 into 3 into 2.
Correct. But then this shortcut we can use if and only if the upper number and lower number is same.
Okay.
Okay. So this was the initial part which I have done. This was not asked, but then always together, never together problems, we always do this. Okay. Now first part of the problem, vowels are never separated. That means vowels are always together. So when I say combine, okay, so O, I, E, okay, these are the vowels. So these 3 vowels will be always together. O, I, E. So this will be marked as first object. This will be marked as first object. And why we are marking it as a first object? Because they are supposed to be together. C, M, B, N. These are the remaining objects, which are 4. So total objects N is equal to 1 plus 4, which is equal to 5. 4 plus this one object, that is equal to 5. OIE is supposed to be only one object because
So
this
I don't
3 letters.
understand. Like there are so many different types of questions. How will we know when to do this?
See, they are very clear. Now vowels are never separated. That means the vowels are always together.
But why will we take it as one object?
Okay, now see, I'll tell you. When I say CMBN, okay. Now this first object OIE. So OIE can lie over here. 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 Right?
But so the vowels are never separated could mean that O, I,
They
E
are
are
always together. The meaning of never separated is they are always together. It's not like the previous problem, no 2 vowels are together. Those are the different wordings. Here they are saying the vowels are always together. So OIE will have to be together. So they are bundled up as one object. They are bundled up as one object. So OIE can lie anywhere now over here.
yeah, fine.
Okay. So how many objects are there? OIE is the first object. CMBN. Okay. Are you convinced?
Yes, sir.
Okay. So OIE is always together, so it is considered as first object. Remaining objects are 4, C, M, B, N. The total number of objects N is equal to 1 plus 4. Total places R is equal to 5 because 5 objects के लिए naturally will require 5 places. So the arrangements will be NPR 5P5, which is equal to 5 factorial.
So, but the places are 7, right?
No. Don't consider the first objects as a separate thing. It is only one object, one place.
Okay, so
Still,
C, M, P. N require 4 places and OI requires 1 place.
Correct, correct, correct. See, practically it is not that way, but then we are assuming it to be one object. But then still the solution is not yet complete. So this is only for these 5 objects. Okay. Now I'll just write and over here because now we have to do something else. This this is very important, this part. And now go within the first object. Within first object. Now guys tell me OIE. This is the first object, right? Will it always remain OIE or there can be certain arrangements inside this? Can it be OEI?
Yeah.
Yeah.
So that's my point. Within the first object, there can be internal arrangements. OI is not always OI. OI can be anything. EIO, it can be EOI or OEI, anything it can be. So there can be internal arrangements. So within the first object, there are 3 objects, total objects within the first object. 3, that is OIE. For 3 objects, how many places are required? 3. So within the first object, the arrangements are 3p3, NPR, 3 factorial.
So
So
we can
total,
also say that there are 3 blanks and 1 is taken by O. So there are 3 ways, then there are 2 and then there are 1.
ha, 5 factorial into 3 factorial. This 3 factorial is specifically for the first object. Okay. And 5 factorial is for the previous thing. So you copy this, then I'll go to the next slide. Let me know once done. Okay. Should I go to the next sub question?
Yes.
So next sub question is the vowels never come together. Okay. So this is equal to total arrangements minus vowels always together. So the total arrangements are 7 factorial without any condition. That's why we did this. Minus vowels never always together. Always together is 5 factorial into 3 factorial. So if we subtract this, we'll get the answer for the vowels are never together. Total number of ways in which the vowels are never together. So total minus total number of ways always together is equal to total number of ways vowels are never together. I hope you have understood this.
Yes, sir.
Third part actually you people know now because it is related to sixth second sub question. So I'll go to the third part. So when I say combine, I'm making 7 boxes. Okay. The vowels will occupy only the odd places. So vowel, 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 vowel. So vowel number one can be arranged in four ways because there are four seats, four boxes, and vowel number two, three ways. The vowels are only O, I, E, yeah? And vowel number three can be arranged in two ways. Okay. So the total arrangements for vowels is like 432. But in one place, any randomly one place of vowel will be not utilized. Why? Because there are only three vowels. So consonants, when I say consonants, n is equal to how many consonants are there? Let us just go back to this. One, two, three, four. Four consonants are there. N is equal to four. Four objects. R is equal to. See, there are three places allotted for consonants. There are three places allotted for consonants, but then one place will be left vacant. Okay. So one unused place by one unused place left vacant by vowels. Okay. We had written that last time. See, one place left vacant by vowels because only three will be utilized. So this is equal to 4. So for consonants, it is NPR 4P4 4 factorial. So the total arrangements for this particular case is 4 factorial into 4 into 3 into 2. 4 factorial into 4 into 3 into 2. Guys, understood?
Yes.
Okay. Let us go to the ninth problem, question number 9. Should I wait? You want to copy something?
I'm done, sir.
Okay.
So,
Question number 9. There are if out of 6 flags, any number of flags can be shown at a time, how many different signals can be made out of them? Okay, I think this problem I have not taken for everyone. Uh, I have done with 6, 7 in the last class. Okay, sorry, let's not do 9, but then let's go to question number 24. Okay, 9 I'll cover it up. You be rest assured. I'll just do it later. Question number 24, a relatively simple problem. How many numbers are there in all which consist of 5 digits? So 5-digit number, so we'll make 5 boxes. They're not putting any condition as in repetition allowed or not allowed. So how many digits, how many numbers they're asking? So certainly there will be repetitions. So the first digit will be occupied from with 1 to 9. Any 5-digit number cannot start with 0. So it will be 1 to 9. The first box will be, or the first digit, the 10,000s place will be occupied with 1 to 9. The second place will be occupied with 0 to 9, 10 ways. Third, 0 to 9, 10 ways. Repetition is allowed. So the total arrangements will be 9 into 10 into 10 into 10 into 10. 90,000 ways. Relatively a simple problem. Relatively a simple problem. Okay. Yeah. Then I had solved question number 18 in class. Question number 18. So I'll take up that particular problem. Question number 18. How many different words can be formed with the letters of the word Bharat? Okay. So N is equal to 6 objects, R is equal to 6 places, NPR 6P6 6 factorial. Okay, so this is the basic part of the problem. 6 objects and 6 places, the arrangement is 6 factorial. I hope you have copied this.
So,
Second,
can you tell, like, when do we use this, like, places and objects, like NPR? Are there any
see,
specific?
if they are asking you the number of arrangements without any condition. Okay,
Okay.
now basically I am expecting some more thing to be done in this, because we have done this in the last class. So 6p6 upon 2 factorial. Why 2 factorial? Because a is getting repeated twice. Do you recollect?
No, so I don't understand.
See, if this a is replaced with this and this a is over here, so will we count Bharat twice or only once?
Once.
Yeah, so to avoid any double countings, okay, the ones which are repeated, that number will come down over here.
Fine. So if it was Bharat may A 3 times, supposing, then 3 upon 3 factorial.
Yeah, a is 3 times then 3 factorial, correct.
Okay, and this is whenever we're getting like the letter
One
more than
particular or
once.
one or more than one objects are getting repeated. Okay.
Okay.
If you go to your previous recording, in question number 22 we have done this kind of things. Okay.
Okay.
Second one, B and H are never together. First I will solve B and H are always together. Okay, B and H, they are asking never together, but then I'll solve always together. So I'll take B and H as one object, as the first object, because they are supposed to be always together.
So, sir, if they say always together for anything, we take them as one object.
Yes. Now remaining objects, remaining objects is equal to 4. Total objects, 1 plus 4, that is equal to 5. Total places, 5. So total objects and total places, NPR 5p5 5 factorial. Okay, but then look at the remaining objects. Look at the remaining objects. 2 is a is repeated twice, so upon 2 factorial. 2 factorial is for a. 2 factorial is for a. But then the solution is not yet over. We have to go within the first object as well. BH will not remain BH, it can also be HB. So that I will write on the next page, but then if you have copied this, then only I'll proceed.
So for never together, will you subtract it from
Ha. But then this is not yet over. Always together is also not yet over.
Okay.
Okay. So after this, I'm going to write and within first object. Total objects n is equal to 2, b and h. Total places r is equal to 2, npr 2p2, which is 2 factorial. Okay. So b and h always together. B, H always together. The answer will be, the total number of ways will be 5 factorial into 2 factorial. 5 factorial upon 2 factorial into 2 factorial. Sorry. So this and this will get cancelled, same terms. So the answer is 5 factorial.
So
Fine?
can you just explain the whole thing once?
Yeah, sure. Why not? So see, basically they are asking B and H are never together. But then instead of solving for never together, initially I am considering B and H are always together. So if B and H, these two objects are always together, okay, so they are considered as one object. The remaining objects are A, R, A, T. Okay. Now since B and H are is considered as one object, okay, so it is counted as one object only. And the remaining number of objects are 4, so the total number of objects are 5. Okay. For 5 objects, we require 5 places to arrange. Okay. So NPR
But sir,
5P5.
in Bharat, there are 6 places.
But then see, iska internal 2 places na, I'm not considering over here. I'm considering over here.
Okay,
Okay.
fine.
Now I was explaining that why are we taking this 2 factorial down? Because there are 2 A's over here. Okay. So down we have to write 2 factorial. So the total number of arrangements will be 5 factorial upon 2 factorial for these 5 objects. Now go inside the first object. Within the first object, the total number of objects are 2, B and H. The total number of places are 2. For 2 objects, 2 places are required. 2P2, NPR 2P2, 2 factorial. So B and H always together is 5 factorial upon 2 factorial into 2 factorial, which eventually gives you 5 factorial. But then the second problem says B and H are never together. So that's the conclusion of the second part. B, H never together is equal to total ways minus B, H always together. Do you agree? Total ways as in without any condition. This thing.
Yes, sir.
6 factorial upon 2 factorial minus 5 factorial. Answers you can calculate on your own whenever you are free. Okay. But then logic is more important. Yeah. Then the last part of the problem. How many of them begin with B and end with T? Third part of the problem. So when I say Bharat, there are 6 places, right? And 6 objects. So the letters B and T are at the start and at the end respectively. So tell me guys, at place number 1, the object is fixed or not?
Yeah.
At place number 6, the object is fixed over here, T. So do we really need to arrange B and T?
No.
No. The arrangements will happen only over here, right? So for this places, total objects N will be 4, A, R, A, B, A, R, A, H, right? We can utilize only these 4 objects. Total places. Can you tell me what are the total places? 4, because the arrangements will happen only in these 4 places. Any doubt?
No, sir.
Yes,
No,
yes.
sir.
Fine, fine, fine. Okay. So arrangements will happen only for place number 2, 3, 4, 5, and the objects are also fixed ARAH. So NPR 4P4, which is equal to 4 factorial upon 2 factorial. Why 2 factorial? Because A is getting repeated twice. A is getting repeated twice. Fine. Yeah. Let us go to the 19th problem. Question
So
number 19.
for this
Yeah, tell me,
one,
tell me. Hmm.
B and T are fixed. So I took like for the places 2, 3, 4, 5, 2 could be filled in 4 ways. 3 and 3, 4 and 2, and 5 and 1. That way I
Hmm.
got 24.
But then,
Then
but
do I
then
have to?
But then you'll have to divide that with 2 factorial, na? Because A is getting repeated twice. The method which you have followed, that is absolutely correct. 4, 3, 2, 1, that is without any hesitation, I would say that it's correct. But then upon 2 factorial will come, na? Because A is getting repeated twice.
But there is a place for A, right? Like,
There is a place, but then see in between, if the arrangement is this ARAH, okay, this ARAH will be over here. So if you put this A over here and this A over here, will you count it twice? ARH, this way of arranging, will you count it twice? No, na, it will be only one because it appears to be one.
okay, so whenever it's in double, we just divide it.
Yes, double, triple, you can just divide it. Yeah. Next problem, that is question number 19. The word is mathematics. They're asking the number of arrangements without any condition. And n is the total number of objects. 11. For 11 objects, 11 places are there. 11p11, 11 factorial. But then m is getting repeated twice, A is getting repeated twice, T is getting repeated twice. So this will be 11 factorial, 2 factorial, 2 factorial, 2 factorial. Basic part of the problem without any condition. But then some objects are repeated, hence I'm taking that thing. Okay, copy it.
Yes.
Yeah.
Second part, vowels are always together. So first object will be A, E, A, I. And the remaining objects are MTH, MTH, MTCS. Okay. So these are 7. Total objects 8. That is 1 plus 7, 8. For 8 objects, we require 8 places. Okay. NPR 8P8. But then look at the remaining objects now. M is getting repeated twice, T is getting repeated twice. So 2 factorial into 2 factorial.
So even A.
A ka we'll do it later. Yes, of course we are supposed to do about A, but
So
then we'll
A
do it.
we take it when we're only looking at that object.
Yes, 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 absolutely correct. Chalo, understood this much?
Yes.
Okay. So this is 8 factorial upon 2 factorial, and 8P8 is 8 factorial, right? So 8 factorial upon 2 factorial into 2 factorial. Now within the first object, within first object, total objects are, how many total objects are there? 4. AEAI. So that those 4 objects can also be internally arranged with each other. Total places are, which is 4 NPR 4P4 upon 2 factorial. Now we'll take A into consideration. So this is the answer. Okay. Now the overall answer for the second part is we have to multiply both the things. That is 8 factorial, 2 factorial, 2 factorial into, and within the first object, that is 4 factorial into 2 factorial. This is the final answer. Okay. Done.
Yes.
I hope you got a clarity about these things now.
Yes.
Okay, now one last thing that I taught in the previous classes, and with this your cover up will be over. Okay, you can write this down. The number of arrangements is also called as permutations of n objects in such a way that first, 2 objects are always together is equal to 2 into n minus 1 factorial. And second part, 2 objects are never together is equal to n minus 2 into n minus 1 factorial. Okay, just copy this and then you can solve question number 20 and 21 on your own. Okay, I'll just help you with that, but first you copy this.
So if we find either one, or like some objects always being together, they're not together, we can do total minus the ones that are together, right?
Yeah, but then see, uh, this particular property is only for 2 objects being together. Okay, so we can directly use this shortcut and find out the answer.
Okay, but what I said
If,
isn't wrong either.
yeah, that's right, absolutely right.
Okay.
But then if it is 3 objects always together, then this method won't come.
Okay.
Then the method which I have taught you now, first object, that will come into picture. Convinced?
Yes.
Okay, so question number 20. Question number 20. There are 10 books which are supposed to be arranged on a shelf. Find the number of ways in which this can be done if two books are always together. So what is the answer? Question number 20, what is the answer? A part.
2 into 10 minus 1 factorial.
2 into 9 factorial. Okay. Fine. And never together will be 10 minus 2 into 10 minus 1 factorial. That is 8 into 9 factorial. And you cannot just multiply 8 and 9 because 9 has a factorial. Guys, you understood question number 20?
Yes, sir.
Yes, tell me.
Yes, sir.
And question number 21 also, you can just tell me the answer. There are 20 books in which two books are never together. So 20 minus 2 into 20 minus 1 factorial.
18 into 19 factorial.
Correct. So that is the end of the cover up. Okay.
Okay, sir. Thank you.
Bye, sir.
Thank you. Thank you. Thank you. Yeah.
Thank you, sir.